We are recording. We're looking at assignment 10, which is due this coming Sunday. And before I start, for those of you that aren't here, that are just watching the video, make sure you look at the study guide for the final exam fairly soon. I'll be scheduling sessions to go over that. It'll probably take 2 or 3 sessions to go over the whole thing next week and the week after, okay? But let's get right into problem 1. So what we have, what we're looking at in problem 1 is a diagram that shows marginal private cost, which is the regular supply curve, or the marginal cost that you're used to seeing. And then we've got what we're calling marginal social cost. And in this case, we're looking at a monopoly because we've got a marginal revenue curve that's a steeper slope than the demand curve. And once again, as a reminder, private demand is always marginal. Well, I won't say that. If there's only one demand curve and there's no marginal social benefit above demand, then demand does equal marginal social benefit, okay? And why I'm saying that, let me just skip ahead a little bit. In this case right here, we're going to look at what we're going to call a negative externality, because the marginal social cost is above marginal private cost. If it was a positive, and I just jump over just so you can see, if it's a positive externality, then we've got a marginal social benefit above marginal private benefit. So if there's a positive externality, then the original demand curve in the market becomes marginal private benefit, and we've got a marginal social benefit that is above it. When there's a negative externality, then demand equals marginal private and a marginal, I should probably put here, I could probably add if I wanted to, equals marginal private benefit right there. Make that about the right size. What is that, about 18? Yeah. So when there's only one, when there's a negative externality, then demand equals marginal social benefit equals marginal private benefit. And just to take that one step further, if there's a positive externality, then marginal private cost equals marginal social cost. There's only one supply because now there's a positive externality, which means we've got 2 demands, right? Okay. In this problem right here, we're looking at a negative externality because we've got a marginal social cost that's above marginal private cost, above the original supply curve for this firm. Okay, now the question that they're asking us, or what they're asking us to do, is to, first of all, in part A, identify the monopolists' profit maximizing quantity. Now, you would do this the way you've always done this for a monopoly, and then the profit maximizing a price. You look at where marginal cost equals marginal revenue right here, okay? The original, the private cost, that's where they're going to produce. So they're going to produce, so the profit maximizing quantity is going to be Q3 right here, right? So this is the same for any monopoly or monopolistically competitive graph that you look at. You're going to, a monopoly or a monopolistically competitive firm is always going to produce where marginal cost, marginal private cost equals marginal revenue, which is in this case Q3. And then from there you move up to the demand curve, and you look at the price of P4, okay? So we're going to have a price of a P4. And we know there's a negative externality because we have a marginal, and I've said this before, we've got a marginal social cost that's above marginal private cost. So what else do we need to know here? Let's go back to our problem. Now, we need to identify the socially optimum quantity or the allocatively efficient, which is always going to be where marginal revenue equals marginal, marginal cost. What am I saying? Marginal cost equals marginal benefit. And so our socially optimum is going to be where marginal social cost as the socially optimum. So we're looking at social cost. So we want to find a point where marginal social cost equals marginal social benefit, which is going to be right here, okay? And that's going to be Q3 again, right here. This is where marginal social cost curve intersects with the marginal social benefit curve right here, okay? So Q3. Now, the next question they're asking, jump over to it, is in the case in which the government imposes a per unit tax equal to the marginal external cost, identify each of the following: the dollar value of the tax using the price labels from the graph, and the profit maximizing quantity associated with the tax. Okay. So if we go back to our diagram, we're going to look at, I've got this little guy right here is going to show you the difference between marginal private cost and marginal social cost. So that's going to be the amount of the per unit tax. And since there's no dollar amounts here, we just simply have to say whatever P4 is minus whatever P1 is. And that's going to be this difference right here, okay? So the answer for that would be the marginal external cost or the marginal social cost equals P4 minus P1, right? P4 minus P1 right there, okay? That's how you would define that. And then the profit maximizing quantity after the per unit tax is going to be Q2, because we move up to where now with the tax, we're looking at a let me jump back here. After per unit tax is Q2. So that's because that is where the once we move up here and we shift up, we're going to actually use this as our new supply, just as if. So why this is confusing is if we didn't have any marginal social cost here and we just had this tax, only the tax, we would still have a higher marginal cost curve right here because of the tax, right? So it just happens to be coincidentally the same. So we're still looking at where the new marginal cost, jump up here, equals marginal revenue, which is right here at Q2, okay? Right there. So that's why the new profit maximizing quantity would be Q2, because we're moving up to a higher marginal cost curve, and we're once again looking at where marginal cost equals marginal revenue, right down here, right? Okay, so Q2. Now, the next question is, and I wanted to show you, first of all, when we're this firm is producing at Q2, the deadweight loss is going to be right here, right? Because this is this point right here where marginal social cost equals marginal social benefit is the socially optimum or the allocatively efficient. So if we're back up to Q2, then this is going to be our deadweight loss. But what they're asking is, what are they asking? Let's see what they're asking. Given the monopoly facing the negative externality, would the deadweight loss increase, decrease, or stay the same as a result of imposing the per unit tax? So it's going to increase because, and this is why this one's a little bit tricky. Before the tax, the profit maximizing quantity was Q3, which is also the socially optimum quantity. So they're making kind of a political statement here. They're trying to sort of, in a backhanded way, say that taxing is bad, right? They should have not taxed it at all. I think sometimes the politics of the test writers come through here, because this could be, this is making, a whole lot of assumptions. It just happens that the tax is the same as the marginal social cost. So therefore, where the monopoly would produce, or where they would actually charge at this point right here, if they were just operating like a monopoly, happens to also be where this higher marginal social cost equals marginal social benefit. So if they were to produce right here, there would be no deadweight loss at all. However, if they were, because of the tax, they're going to produce where the new marginal cost curve right here equals marginal revenue, which drops them back to here, which means now we're going to have a deadweight loss. So the answer is that deadweight loss as a result of the tax will increase from a 0 to whatever that was, okay? So you would say, so the way you would explain that is you would just simply say that the deadweight loss will increase because the quantity produced after the tax Q2 is less than the quantity produced before the tax Q3. Before the tax, profit maximizing quantity Q3 just happened to equal the socially optimum quantity Q3. And after the tax, the profit maximizing quantity Q2 is obviously less than Q3. Okay? Any questions? If not, you just go like that. You're good. You're good. You're good. Julie's good. Okay. All right. So that's not all that hard. These are just a little bit tricky because they did because the tax was the same as the marginal social cost, which made that a bit weird. Okay. So let's go to the next one. This is we're looking at the market for fireworks with a negative externality. Now, this is sort of an interesting problem because fireworks, if you like them, if you enjoy them, if you love fireworks, then you can say it's a positive externality. So when a neighborhood or a city or a town has a fireworks display, for the people who think they're noisy and they can't sleep or whatever, they can't do what they want to do because they're too loud, for them it's a negative externality. For the folks in the town who enjoy them, it's a positive. So it could be either or, depending on the eye of the beholder, right? Beauty is in the eye of the beholder, isn't it? So this is sort of what they're saying here. So what we want to know is, and the way they set this up is they just tell you that Okay, so these are fireworks that people are just setting off in their backyards. So they're not like a big city-wide professional display. So, and they're saying that the market is perfectly competitive, and they want you to draw a graph that shows the market equilibrium price and quantity labeled as P sub E and Q sub E, and they want you to assume that the noise from the fireworks disturbs the neighbors. So you're going to consider fireworks as generating, in this case, a negative externality. And they want you to draw in the marginal social cost curve labeled MSC and the marginal social benefit curve labeled MSB. Okay. And they want you to label the deadweight loss. Okay. So what does that look like? Looks like what I showed you. So it looks like this. You're going to go a P sub B, a Q sub B, and then you're going to, because the neighbors don't like it, because the key here is that it disturbs the neighbors. So that's how you know for these neighbors it's negative externality, which means there's a marginal social cost higher than the marginal private cost, which you would draw up here, right? And then that would mean that you would really, in order to find the socially optimum point, in order for this cost to be taken into account in the market, you would actually want to produce less fireworks at a higher cost, so that the neighbors wouldn't be as disturbed, because fewer fireworks would be purchased and there would be less noise, right? If they were more expensive up here. So when that happens, you create a deadweight loss because we're looking at where marginal social cost right here. I'm trying to get this guy. Shoot. Trying to grab this guy, but I'm probably not. There I go. The marginal social cost right here. And this is a little bit tricky. It's kind of a backwards deadweight loss, right? So you want to draw it in where you use the triangle here between where, if you go straight up from where they would produce in the market right here, and then go straight up to where you've got your marginal social cost curve up here, and then draw the triangle in right there. This is going to be the deadweight loss that's created by what? Okay. This is the deadweight loss created. This is why it's a tricky, created by the negative externality, right? So it's kind of like going the other way, right? You're used to seeing a monopoly where they produce less than optimum, right? The way you want to remember this is when there's a negative externality, the private market produces more than the optimum, right? So that turns that deadweight loss triangle around. And so instead of it looking like you're used to seeing it like, just grab one up here, move. Instead of it looking like this, if I can flip this guy around, instead of it looking like that, right? This is what you're used to seeing, something like that. It looks the other way because you're looking at, this is the optimum right here. This is the optimum. And they're producing more. So by producing more and creating noise that disturbs the neighbors, this negative externality or higher marginal social cost is creating this deadweight loss right here. Okay, does that make sense? Like that? Does that make sense? Good. Okay. Now we're going to look at the fireworks from a different perspective. We're going to look at it from the perspective of people that like them. So now assume instead that all the neighbors enjoy watching the fireworks. In this case, is the market equilibrium quantity of fireworks greater than, less than, or equal to the socially optimum quantity? Now, I went ahead and drew the graph. It's not telling you to draw the graph, but it helps to draw the graph with the positive externality, just so you can see better the answers here. And also, you don't know that you may get a question on the actual exam that wants you to draw this graph as well. So it's good to be able to draw it. So let's look at what that would look like. That graph would look like this, okay? You would have a marginal social benefit higher than the marginal private benefit. So you'd have a demand curve that's to the right and higher than the private demand curve, and this shows you the positive externality, which means that the market, when there's a positive externality, is producing less than the socially optimum. The socially optimum is right here, right? Where marginal social benefit equals marginal private benefit right here, okay? I mean, I said that wrong. Where marginal social benefit equals marginal private cost and also a social cost, because they're equal, okay? Right there. That's your socially optimum point. So in this case, with a positive externality, the market equilibrium, we're marking that as QE, is less than the socially optimum quantity, which is higher up here, okay? Now, if fireworks displays, well, let's go back. So now we're looking at a deadweight loss the other way, because if we're going to produce here, then if see how it's a flip. See, here's your deadweight loss here. When we have a positive externality, the deadweight loss looks a lot more like what you're used to seeing, right? Because we're producing less than optimum. So that's your deadweight loss right there. Now, what they're asking, though, they're asking something else. They're saying that if there's a positive externality in this case and the government bans fireworks, in other words, zero production, will the deadweight loss increase, decrease, or remain the same? Well, if there's zero quantity produced, think about it. If there's zero quantity produced and the optimum is right here, and the government says you got to produce zero way back here, then the deadweight loss becomes this. So yeah, it gets huge, because all of this now is deadweight loss because we're this far from the optimum, because a zero is here. Zero, if they're banned, quantity is zero, right? And if the optimum is way out here, then this is our deadweight loss. So it obviously increases. So you can say if a fireworks display constitutes a social benefit or a positive externality, and the government bans fireworks, the quantity produced would decrease to zero, and the deadweight loss would increase. Does that make sense? Is that good? Okay. So that's problem 2. Okay. All right. Problem 3. We're looking at another example of I believe, positive. We're going to look at. So suppose research shows that the more college education individuals receive, the more responsible citizens they become, and the less likely they are to commit crimes. Okay, probably because they have a job and don't need to commit crimes. Draw a correctly labeled graph for the college education market and show each of the following: the private market equilibrium, quantity and price, the label QM and PM, and the socially optimum quantity of education labeled QS. Now we can see by how they're by the narrative here that we are generating a positive externality, because once when a student pays for a college education, they're actually, society as a whole is actually gaining a social benefit, less crime, right? So we're going to draw this as a higher marginal social benefit curve. And we're going to label the socially optimum quantity where marginal social benefit equals marginal private cost as QS. And we're going to shade in the deadweight loss. So let's stop right there and do that, okay? So let's jump back over here. And this is what is eventually going to look like. But for now, you're just drawing, let me go back. You're drawing QM, PM, and they want you to label, let me jump back over here. They want you to label the socially optimum quantity as QS, okay? So that's going to be right here, okay? So you need to draw in your demand one, I just said demand one, which is your marginal private benefit. And because it's a positive externality, you're going to have a higher demand two curve, which is your marginal social benefit. You're going to mark where marginal social benefit equals your supply equals marginal private cost equals marginal social cost. This curve right here, where they're equal, that's going to be your socially optimum quantity, mark QS, right? You're going to mark your market equilibrium quantity, QM, right here, the original marginal private benefit equaling the marginal private cost right here, and the price at PM. So that's what you're going to have so far. And then you're going to add some things when we look at the next question, okay? And then I'll go over, and then I'll go over all the answers. But let's just get through. Let's see what the next thing is. Okay, so now part B here is we're going to assume that the government imposes an effective or binding price ceiling on the price of college education. Show the price ceiling on your graph, labeling the price ceiling P sub C, and then they are asking you, does this price ceiling increase, decrease, or have no impact on the deadweight loss in the industry? Okay, so with a positive externality, we know without the price ceiling at all, we know that we've got a deadweight loss right here because we're actually producing below the socially optimal, okay? Now, as you should remember, a price ceiling that's binding or effective is below, it says the price can't go above the ceiling. So in order for it to be effective, it has to be below the market price. So we're going to draw it right down here. You can draw it anywhere you want to, as long as it's below the market price. So I drew it down here, and then you can see that with a price, if we're going to charge students a much lower tuition, then there's going to be less education available. So the supply drops down from here down to here. So if this is the new quantity produced with this price ceiling is going to be where the price is equal to the marginal cost, private cost, which is right here, right? Which means that we're going to produce less even than we are up here. So we get farther away from the socially optimum point, which is way out here, where marginal social benefit equals marginal social cost. This is optimum. This is where they're producing in the market, and with the price ceiling, they're going to drop down and produce here, which means the deadweight loss goes up to something like this, right? Much larger. So the answer is it increases with this effective or binding price ceiling, as you can see on the graph. Let's see what else. So then it's asking, so we know that the deadweight loss is going to increase, and we know why. Now we're asking, assume that instead of the price ceiling, the government grants each student a subsidy for each unit of college education purchased. Will the new equilibrium quantity of college education purchase be greater, less than, or equal to QM from part A? So if there's a subsidy, that's going to mean that cost goes down. And so that means that, let me see what I wrote here. So what would happen is that if there's a subsidy, this is kind of a tricky. Let me read real quick what this could be, because this is going to affect demand and supply. So so what I wrote here, as you can see, was that if the students who are demanding education get a subsidy, they're going to demand more, right? So that's going to shift the demand curve to the right, which means quantity is going to go up, right? So it's going to go up. But I think, in the book answer is very short. It just says it's going to increase. But I want to get more into it. Why would it increase? Well, the demand could shift up because if students don't have to pay as much, then more students are going to want to go to school. But also, if there's a subsidy, that technically makes the cost go down, right? So that say a course costs the school $1,000 and there's a subsidy, the students get a $200 subsidy from the government, they're paying that to the school. So now the course, let me think how that would work. Would that actually make the course cost less? Let me think here. If the students had a subsidy and they paid the subsidy to the school, it could make the supply curve shift down to the right, which would also, but the bottom line here is, and the answer that you want is that the new quantity with the subsidy is going to increase. Okay. So more students would be going to school. More courses would be taught overall. So that's why I marked QS right here. But it could be anywhere. I mean, you have no idea how much the subsidy is, so you have no way of knowing exactly what would happen. But you do know that there would be more courses being offered with the subsidy. Okay, and that's it. I think that's everything on that one. Yeah, I know you can. I know that I can't hear you. I'm sorry I can't hear you. But if you have any questions, you can make sure you send me an email. Okay. And is there anything else? So tomorrow night we're going to do a session at 7 p.m. Going over the Quiz 10 study guide. Right, and we have one more assignment and one more quiz, assignment 11 and quiz 10, quiz 11 before the final. Okay, and once again, I'll be scheduling sessions to go over the final exam study guide next week. Okay, is that good? Okay, I'm going to stop the video. Whoa, stop the share. Okay.